We're back today with more coding stuff. I'm actually going to continue the series where we're going to take a break for a while from the DSPy stuff because it's getting kind of complicated. But I wanted to continue the sort of the project cleanup I started. And I actually was looking, maybe we'll do some slight functional changes today, but we know the UV stuff is already done. We'll go over that. But I wanted to do something else, which is to refactor the way we handle configs with a modern pair solution based on Hydra and OmegaConf. So let's go to our favorite drawing board while we think about stuff. Well, actually, let's take a quick look at Hydra and OmegaConf because I want to use the pair of these two because I've been having some good experience with it. And let's also open the drawing thing, which we like to do. Okay, there we go. So let's see. Okay, this is a nice recap for what we did last time, right? So that reminds me, I forgot to rewrite the docs, which we probably should do. So we need to. Let's see. So we need something like improved readme.md. I have to still do this. I forgot to do this because we changed a bunch of files around last time, and we reorganized the project using, well, two times ago we did it with UV, but we did the mono module way. Versus we split the project last time in multiple sub-modules, right? So we used to have a ton of loose Python files called train underscore whatever and test underscore whatever. So now they're organized into folders, which is supposed to be a lot better. And that's pretty much it. Oh, and we also did this big reformatting, which was a gigantic change, but nothing functional. We just reformatted the whole code using rough in a one-liner. And I know there is one other thing that we need to do. I remember there's a... let's see, where would I add this? So we need to improve the README. We need to add missing data files. Specifically because we found some stuff that doesn't run, and apparently it never ran while this repo was collecting stars online. And also nobody complained about that, but it's better to fix things than have them be broken. And okay, so that's that. Now, here's the thing though, because this is all nice and good, but still, if I look at some of these scripts, they look kind of messy. Let's look at what we mean by that. So let's look at train score, for example, right? So now we have source train score. Okay, here it is. This config is a disaster because at the time, many years ago, when I didn't know much about clean coding, I used this very convenient .map package, which is just a way that allows you to use the dot in Python. Well, now more formally speaking, the dot represents an attribute, right? So this creates a sort of Python object with nested attributes, which you can define on the fly, right? So even if I type config dot blah blah, I don't have to predefine that field anywhere. I can just say something, and this code will run, and config will automatically have the attribute set. The only redemption is that it does support nesting, right? So you can do stuff like config dot blah blah dot whatever equals stuff. This will still work at runtime, and it will automatically create this nested structure, which I remember is why I liked it at the time. That's pretty much it though. The thing is, there is a modern way to handle this stuff, which is through Hydra and OmegaConf, where you predefine and you also type all these configs. So another big thing we're going to do today is we're going to introduce static typing in Python, which is pretty much needed, right? So if you don't know static, so there's a hint here that I can't even do type annotation for stuff like this, but generally you're supposed to type everything in Python today, right? If stuff is not obvious, and it's definitely not obvious what it should be here, right? Because somebody has to read to figure out that this is a string, this is a boolean. Sometimes you want to type, maybe we have to have hybrid config options that are boolean or string. So I would like to have something like, for example, variable. It could be a string or an integer. Is now there's another problem here because I have to set the default, which has, it could be something like this, or maybe I have some really critical, or I have, let's say, a critical variable that's an integer, or that's a list of integers, and I wanted to declare it missing, which is a special attribute that tells you the program will not run if the user doesn't supply this from the command line, right? So then you want the user experience to be uv run -m score score based channels dot train dot score critical variable equals, what do we say, a list of integers 1 2 3, because you want to force the user to be aware of what they're doing, right? Instead of, now having defaults is a good idea, but maybe you want to leave 1 or 2 critical variables just not be set. That way, when anybody tries to run your code, you're forcing them to think about and set that. Hello, we have somebody in Twitch. Thanks for joining. I was just going through what we want to do with OmegaConf and Hydra. Oh, thanks for the follow. So we want to have some experience like this where we have a critical variable that's missing. Another thing you can do with OmegaConf and Hydra for your program when you run it is you can it automatically validates stuff for you. So then if you set the critical variable, let's make this simple, right? So let's say I have some parameter and I run with uv run -m critical variable, it's an integer, so I want this to be 2. What if a user runs this with blah blah? Okay, so somebody inputs a string. Well, OmegaConf automatically handles that for us. It's immediately going to throw an error. Okay, so it'll say, no, you can't use this variable here. It has to be an integer. Now, if I had typed this as integer or string, this will go through, but then something like true, which is a boolean, would have failed. The other thing you can do is you can add validation methods. So you can write a small validation method inside the config, okay? And you can just validate if critical variable greater than 5, raise value error. Actually, you know what? Let's just do this directly. What the heck am I doing? Let's just do this directly, right? So we'll call this a play.py. Okay, so before we plan the diagram, let's try to emulate a very, very small demo of, okay, so if you joined later, this is what we did last time in the repo that I worked in grad school, the score-based channels repo, which is somewhere, it's in the description of the previous videos, but we sort of reorganized it to use UV, and also we split in multiple Python modules. So no more loose Python files in a single folder. Proper submodules within it.py, train, test, and utils. Also, we did a giant ass UVX rough format, which reformatted all the code. So it looks a lot better. Now these, I didn't push these to public yet, but I think we can, well, we'll do that actually. We'll redo all this on our playground script. And I still have to finish the README and some missing data files. But before that, let's mess around with OmegaConf. Now, the one I like to use, and Hydra. Now, why are there two packages? OmegaConf, I like to use structured configs, which is really a Pythonic way. Here it is. So what they have you do is define the data class, which represents the command line parameters of your program. Now, you can do this with argparse, right? Argparse is like the canonical, let's see, argparse is kind of perfectly fine, except it doesn't have these validation methods, which I'll show off right now. So Python has the whole built-in. Okay, so let's build our own small config. Now, the other package, so you do this config with OmegaConf. You have to read it in with Hydra, because Hydra also gets you command line overrides, right? So Hydra is closer actually to argparse. Well, they kind of work together, right? So actually we should sort of start from, we should start from this example. Let me see, Hydra with OmegaConf structured config. It's an advanced tutorial, yeah, we know, are available here. Yeah, we want something minimal. Okay, there we go. So this is everything we want. So let's start working on this one then. Now, another thing is because we switched to UV. Had we not switched to UV, we would be dead, because we would have to sort of... we would have had to somehow figure out the dependencies again, but that's not gonna work. All right, so UV add Hydra core 132, and we're done. It brings, okay, there we go, finally. Okay, sorry about that. So okay, now let's go back to our very small example here to show sort of the power of config management using Hydra and OmegaConf. Okay, so now I can run this thing, UV run-m, score-based channels. Where did I put this? In train, play. And it's just gonna print something. Okay, so it prints host, localhost port, because these are default args, right? So now there's a, let's play around with validation. So data classes, you can define a method called, I believe it's post init. Okay. And we can say if port greater or equal than 4000 or port less than 2000, raise a value error. This is self port because this is a class, it's a data class. Okay. Invalid port value self port must be between 2001 and 4000 inclusive. Okay, so now let's see what happens if we try to run uv-run. Okay, we can write port equals 3305. Well, this works. What about 4001? obviously it's I'm forgetting how to do. Let's see. OmegaConf post init. Right, this is exactly the and why doesn't this work? If self port or is it not typed like this? Oh, I think I know what. Oh no, it is post init, right? Yeah, it's post underscore init. Why can't I do validation on this? What if I try to do 19999? No. So I do CS store config. Oh, because I have to run the, I know why. So we do config equals OmegaConf. Okay, there's a trickery here. So let's see. From OmegaConf import OmegaConf. And you do, how do they do it? Maybe this person shows us here. Config. Yeah, here it is. This is actually the same issue. The validation is not run. Yeah, I have to do from dict. Let's use a keyword expression. Convert the parse dict config into a MySQL config. No, thanks. Copy my response feature should be against like I post independent on structure config. Currently methods not supported. So I have to use two objects. Yeah, this is the thing here, right? So I have to use config. Two object. Two object. Okay, I think this is gonna do it. Yep, there we go. Okay, so you just have to convert this to an object. Am I typing this right? Or should be config dict? No, this should be fine right now. If I do 2001. Okay, there we go. So now you can validate args. You can also do multiple validation, or you can say if self host not in. You can only allow some hosts in your app. Web. Raise value error. I'm not gonna type the whole thing, right? Invalid host. So then you can also override two things directly from Hydra, right? So let's say I want to set both the host and the port. You can do it in any order. So I can go port 3000, host equals stuff. Well, this should crash because invalid host. Then I can say host web. Okay, which works. Let's do a missing one now. So we can call this app, which is a string. Let's call it a string, but there's a special, I think it's in OmegaConf. Yep, it's a missing. So now what happens is if I try to run the app, Okay, so it's gonna yell about has missing mandatory value app. Okay, so the app, your program will just not run. So the user has to do this, and let's also use it, I guess. Print host config app config.app. Okay, so the user has to specify this just to run your app, which is kind of what we want to do for very, very important parameters. More stuff. You can do nested data classes now, which we also need in our project because remember, that's why I used to do all these silly dot maps, right? Because and it kind of makes sense in a complex app, especially with AI and stuff. You want to have a part of the config that configs the model, something else that configs the optimizer, training stuff, data, a bunch of stuff. Well, you can do nested data classes in Python, right? So we can have a data class. I'm still gonna work. Let's do a nested data, like we can have a port config, okay? Which has number, which is an integer, okay? And let's say it's missing because it's an important one. And it has like a range or something, I don't know, IP, okay, which is also an integer, and it's 1000 by default, and it has its own validation. All right, so let's do a more complex example, because you don't have, now we can move this port validation from here to here. Okay, so now what do I do here? Because I don't want to repeat this. Now instead of port, I can type this to be a port config, okay, and I can either put this as missing, or I can give it also partial defaults. Let's give it the partial default. So there's something called a default factory port config, and where is default factory from? Python OmegaConf default factory structured config default. Oh, here it is, default factory lambda. So you give it a list. There's a trickery here because for complex data structures you can't just type the list, you have to use this default. Where is default factory imported from? Python default factory. Oh, it's from data classes. Okay, gotcha. Default, is it not from data classes? What the heck is this? Oh, it's field. Ah, my bad, sorry, it's field. Okay, so I have to import field. Okay, and then we say this guy is field with the default factory, which is a lambda function. Do I need to say lambda x, or is it just lambda? No, it's just lambda. It doesn't have any args. And it's a port config with a number of 2500 and the default IP. Okay, so this is getting pretty complex. So now if I run the app, first of all, let's try to run the app by itself, right? So uv run -m score base channels dot trains play. This is not gonna work because sorry, self number here. Okay, so again. Okay, so the first reason why it doesn't work is because the user didn't specify one of the missing parameters, which is app, which is supposed to be a string. So that we knew, right? So first, if you ever, this is like okay, so then you can say app stuff. This is like an important parameter if you want your, if you want to prevent users from running your app without them thinking hard about what to pass, you can just put a missing there. Now, okay, so this works and it prints. Okay, now we need to unpack. We don't have host anymore. We have, the print is wrong here, because now this config is exactly a nested dot object, which I managed to mirror what I didn't know many years ago. Because now if I go into config.port.number, I reach into this number here, right? So we can redo our print. So port number, which is port.number. And what is the other one called? Port IP. Config.port.ip. Okay, let's run the app again. Okay, so we see, let's see, are we printing the right thing? So app is stuff, the user passed that, that looks good. Port number is 2500 and port IP is 1000. Now those are good because the default 2500 comes from here, despite the number being a missing parameter. Had I done this, this would crash. Because yeah, there is no number, right? So it's trying to compare missing, and it can't compare missing with 4000. But then if I run the app like this, I have did I not save? Okay, I hadn't saved. Okay, so now this works, and then I can override stuff nested from the command line directly, right? So if the user wants to say, you know what, I just want to run this on port.number 33333. Okay, well this works directly now through Hydra. Now the validation steer is still active, so if the user puts port 5000, this is gonna crash because it hits the internal validation in the post init of the port config. And I think this is as complex as it's gonna get because I have a bunch of stuff here, and some of them have options, right? Like optimizer should only be Atom or SGD. You don't want to let the user to override with whatever they want, like banana. Booleans are type checked by default. Lists will deal with it. And that's it. That's pretty much it. So I just want to refactor all these into command line apps with Hydra and OmegaConf. And of course, we already did the UV part. So let's mess around with... Okay, so we have all this stuff. So we'd like to go from... Let's try to systematize this, right? So we have a dot map object in submodule.py. We'd like to instead go to a train config, a data config, model config. I don't remember what else we have here. A bunch of weird things like, oh, optimizer config, and I think that's it. Oh no, there's a, because this is the fusion models, there's got to be a oh, I see, the test will have a sampling config for sure. Oh no, the test just loads. Okay, so we're gonna have to refactor things a bit here because the test loads. Okay, this is a good test actually. I've never done this because we want to save this config to disk too, so then somebody can load it. Okay, all right, then we want to override. Here it is. So we do a deep copy. This is not the best way to do this. Eek. So the training scripts, okay, these, okay, so let's see, these can, what else do we say? Optimizer config. And all these should live under, there'll be subfields like we saw of a thing called Hydra plus OmegaConf app config. Now this is fine-ish, but, oh come on. We also want to save this to disk, right? Save to disk. We need a reload, which... reload. This reload is gonna be something. Well, okay, let's actually tackle that head on, because let's say we don't know how to do it, right? So we're not... Now, one way to do it is to Google it, okay? So you can go just how do I save an OmegaConf to disk? But sometimes I like messing around with it myself. So let's say the way I do it is let's just stop in the debugger here. Let's see what the heck is this CFG object. Because if I can just do torch.save... Now there's another thing here, because I should not be using torch.save for... but maybe torch is fine, because it's probably H5 based file format. But I want to see, can I even save that? So let's try a torch here. I'd like to look around at that object to see, is it... So the Pythonic question is it serializable, right? That's what Python calls serialization. Can I save it to disk, and can I reload it? Very importantly, without... there's gonna be a trickery here. I will not be able to reload it without importing these classes, I think. I'm pretty sure it works that way. So let's try to run our app again. So uv run dash module score underscore base channels dot train dot play. I need to specify an app stuff. And what, it jammed? Oh, okay. Somehow it jammed. Weird. Okay, so I'm here. Good. So I stopped right there. So I have the CFG now. So it's an instance. Okay. So the CFG itself, it's an instance of the yeah. So I can try a torch.save. Oh, I know why it stalled, because I had to, I imported Torch for the first time this session, since I restarted the PC. What was the syntax for torch.save? Save an object to this file, pickle, object file. So, let me try to save it directly, right? Attempt.pt. Okay, sure. If I try to reload it now, torch.load. Nah, but not here. Not reloaded here. There's a scam because I already have the... Well, okay, fine. The thing is, it may work here, but I already have the data classes imported. Torch.load attempt.pt contents. Yeah, so this can be loaded. Okay, now the million-dollar question is, if I exit this program and I stop here before defining the data classes and I run the app again, does it work this way? I think, yes, I'm stopped here. Okay. Now, if I try to load that again, is it gonna work? And I would guess no. Maybe I'm wrong. Nah, I'm not wrong. Okay, so the thing is, you can save this to disk, but you can't load it unless, so that means all our test code we'll have to import. It gets a bit nasty because you have to import the nested data. Like, I don't only have to import my SQL config, I have to import. So if in our case we're gonna have, if I have 4 different configs and the big one which organizes everything, I'm gonna have to import 5 things. Not the best, to be honest. This is why I like that dot map. Right, because I'm starting to remember now. Well, I'm pretty sure my reasoning was not this complex at the time, but this stupid dot map thingy, as stupid as it is, it's sort of It's just an order dict. Okay, so it uses a basic Python structure, which doesn't need you to reload the class, the data classes. Let's go to Gemini for this one. So how to serialize a data class instance and load it without importing the data class. If possible, serializing data class is a high level. We want to parameter that serialize some data class instance JSON. Deserialize back to your original data class. Yeah, this is what we want because this is nested too. Sure, serialization is relatively easy, right? Of course, because there's an as. Okay, sure, you can do it as dict, and that's it. JSON dumps. Here it is. So if you just load this, you have plain dictionaries instead of instances or data customs. Decode all the values. Okay, so we need to know the desired data class. There's no other way to do it. Then no, I don't like it. So is it possible to serialize data class info together with a data class instance in Python such that when I load the file it automatically maps. This doesn't sound possible as I type it out. Data to the class without me having to import the class. It's gonna be something either nasty or it requires the class definition to be available. Yeah, this is not what we want. Yes. Okay, so you need a library. Okay, I see. So standard pickle saves pointer. Dill saves the bytecode. So you can basically jam the whole class. Truly portable. Doesn't need your original Py file. Dill dump. This saves definition of hero into the file. What do we do? Should I do this is kind of nasty though. Python dill. You know what? We have UV, right? So this should be like a no-brainer. So then I can just go and do UV add dill and it automatically figures out everything. There we go. Yeah, let's do it then. We'll do it the dill way. So then I can go do, what is it? It should be pretty easy, right? Let's do it because we get rid of the import torch. Yeah. Okay, this is a lot better. The torch.save, which is like really a crude way to save stuff. So then I can do dill dot, what was it, dump cfg oh, of course. Okay, so I have to open something too. I see, to a file pointer. So okay, we'll do it this. Okay, so with open cfg.pickle or let's call it attempt.pickle. No, let's call it cfg.pickle. Okay, we can delete this. Write binary as f, dump the config into f. Okay. Now I can just run a Python instance with UV. And let's see, file is cfg.pkl. So how do I import dill? I'm curious, what are we going to see? So how do I load back from dill? I should really be reading the docs. Python dill load. loads from dill import load. So dill dot loads. Oh, I should be using dumps then. Oh, no. So loads. What does this guy say here? Load, I guess. Sure. Okay, because I'm in the console, I have to do this manually, but it's fine. So F is open file read binary bytes. Okay. Contents, or let's go to CFG. Dill dot load F. Interesting. So what is this now? Ah, so it has the... This is wild. How does this work? So do I have visibility into this now? Like it's actually loaded? No, I don't have the class. It's not as if it's also loaded in the namespace. I guess this is fine. So we'll see it like this, but we're not... If we want to actually use that, we'll still have to run import. But we never want to... And I can do deep copy on this, right? Copy.deep copy, CFG. Yeah. Can I edit it? CFG.app is more. Yeah, I can. Okay. Can I nested edit it? CFG.port.number is 33. Okay. I also... This is why I bypass validation here, because this is not called post init for no reason. This only runs once after it captures the command line, right? So users can do hacky stuff like, I have an invalid port number now, but they edit it by themselves. Okay, good. So yeah, we're using the dill thing. Okay, that's it then. So back to the... where was I? Okay, here. Okay, so save. So dill.dump cfg.pickle f and dill.load f. That's it. So today we want to port all our apps from this let's call it monolithic. Okay, again, this is kind of the design principle we did last time too, right? From a monolithic module to nice sub modules. Same thing, we want to port the config over to a modular config. And very important, there's another thing here. We also want to have a defined main. Okay, so all this should live in a main.py. Not main.py, but in a define main function. Because we want to turn each of the scripts, because now we have loose files. We still have loose files here, right? Yeah, modules should not, like, we're just gonna want to indent all this stuff. And of course, we're gonna have to nuke the arg parsing. Ah, okay, wait a second. So, okay, so inference scripts are even more complicated because they load the config and they have their own okay, good. So we're gonna migrate this too. So we're gonna have to migrate our, okay. So there, I forgot there's also monolithic arg parse in so we have monolithic dot maps in train dot sub module, and we have monolithic arg parse in test dot sub module, and we want to get rid of everything. We want to use Hydra and OmegaConf everywhere. Okay, that sounds pretty good. So we're gonna have to replace all of this, and yeah, we want to switch. Switching will be easy because we just want to indent all this stuff to a main function, tab, and then just say if name. This is big because it allows us to import from these modules if we ever want to do that. So then we can work on actually functionalizing some of these modules. Because right now the biggest problem is I cannot import from these, right? If I go into Python and I say from score-based channels dot train dot score import something that I'd like to import from here, I don't know, the train seed, this actually runs the whole code, right? So I can't do that. Instead, what I would like to write this into a get seed function, and we can import that function and run it modularly. We'll think about if we actually need that. Yeah, there is some math here that okay, yeah, so I just triggered the whole training run, which is so basically even okay, another way to view it is, had I had a function here do stuff, okay, x return x, if I now try to reuse this, okay, so I go from score based channels dot train dot score import do stuff, it still runs all the module code, because that's how Python works, right? All the code that is main level, it always runs. So I can't reuse this function now because it runs all this code, which includes a giant ass training run and saving the model. So at some point we'll want to split these into pieces. Okay, so let's start working on the config for good now. So no more play. We'll leave this here because it's useful. We'll start with train score. Git stuff, gotta be careful. So I'm on my I'm on my fork, git status. What did I change here? Did I change anything? Yes, I did. Well, before that, so what branches do we have? Okay, so we already have a branch. We already have a pretty significant tree here because rough format has branched off of add submodules. We're gonna branch again off of rough format. So git checkout B. Hydra and OmegaConf off of rough. What was it called? Rough. Oh shit. Rough. Rough underscore format. Okay, so we already did some changes to PyProject because we added. Okay, we added dill. I would like to add uv add dill. I like to pin the versions exactly. Okay, so git diff PyProject. Okay, so we're gonna have to lock now. Okay, we locked. So we can add the dependencies because we added Hydra, which drags OmegaConf with it. So add dependencies. That's done. Did we do any changes to score? We should not do this change. Okay, now. Okay, we're clean now. Okay, so let me start actually, let me do the main thing, right? So if name is main, we're just gonna do it the basic way. We'll just run main and we'll call this whole sausage main. We'll split later. Whole sausage means eek. Interesting. I don't think I need this anymore. Yeah, let's clean that up. Not sure why I was. Yeah, that looks really bad, so we don't want that. So this is the whole sausage. Define main. But hang on, because we forgot. We need to do it the Hydra way. Okay, so this whole thing gets tabbed. Okay. But we need to actually, we already need to do Hydra stuff to this because it has a decorator. So Hydra wants you to decorate. So now Hydra handles all the, it automatically gives you arc parse, right? But it has its limitations because you have to decorate a single function in your module or Python file, but it's called module. You have to decorate a single function with hydra.main. It doesn't work for two because then Hydra doesn't know which entry point you're trying to run. I don't think it works. I wonder if it does work that way. You would think it does. But okay, so config name is do I need this version base none? I guess I do because it's unspecified. Config name, we'll leave it config. Okay. The other thing you have to do is you have to register the OmegaConf config at the highest level. So for that we'll need from Hydra config store. Okay. Now what name do we want to give it? I don't like config. Now the idiomatic name is to give it train.score. No. Train underscore. Wow, this looks really bad though. What the heck? Now. And what? This is supposed to be train score config? I guess so. This is not the end of the world, right? Yeah. Okay. It is kind of a sausage name, but sure. Okay, let's shoot a quick UVX rough format because we want to reformat this because it's annoying me. Score-based channels, train, score. Okay, so it's a bit of spacing issues and stuff. We need no, it's not. It's from data classes. Import data class. So this should be somewhere here. Whoops. Oh. Okay. So now we need to start building this config. So data class, train. Oh no, I think what? How is it? It's a class, right? Yeah. Class, train, score, config. Okay. Stuff equals 0. So we're gonna have to start moving all this stuff. So device. Now we want to keep these here. Oh my god, this also had arg parse. Oh yeah, it had GPU and train. So where does train go? What do I do with args.train? Oh, it's data chain. What do I do with args GPU? Okay. Oh, wait. Okay, so sure. So we need a GPU. Let's do a trick here. Let's have it be an integer and 0. For scalars, you don't have to do the default factory thing. You can just put equals 0. So now if users run the app without so actually we can gradually test this. Okay, so let's say we only do GPU 0. Now, we need a tiny post in it here. Actually, we can do a pretty fancy post in it here. So verify that GPU is valid, okay? And convert integer to torch.device. So what do I mean by that? Because if you notice here, I want here. So actually, let's not mask this. Instead, let's just have the device be CUDA1 directly, right? Because I'm doing a hack here. What I'm doing is first I mask the GPUs to only 1 with that integer. So let's say this would be 2, okay? And from this point onwards, the PyTorch only, well, yeah, PyTorch only sees 1 GPU with index 0 because I mask it on the machine, which is not the, let's just target the GPU directly. This one you don't need these days because it's like, well, actually no, that's not true. You need this. So let's leave this now. So we would like to have self device equals CUDA self GPU. That's it. So, and this is a post init thingy, right? So after the user passes this in, and then we can use config and config.device, and we're done. Okay. Now let's also parse the config. But wait, if we, let's see, how should we do this? Because we actually want to test this incrementally, which is not a bad idea at all, actually. So we're gonna do something horrendous because, so sorry, what am I? Oh, I see, my app. Okay, so my main has to depend on CFG, which will be an instance of train score config. Okay, and I need to unwrap it with the trick we did here so that, yeah, I need to just run this tiny thing here just so the post init runs. So from OmegaConf import OmegaConf. Okay. So now I have two configs. The reason I call it horrible is because now it's CFG. So let's temporarily call this Hydra underscore CFG. Although that's a bad name. You want it to be CFG, but just to distinguish it. Because what I want to do is, and we can test it just by Hydra CFG.device, by taking from it, right? So let's see if this whole thing should work now. I'm gradually replacing in my app, right? Because I have a GPU. Oh, I didn't verify it's valid, right? So I think Torch has a thing here. Torch num GPUs, because we want to, oh, here it is, CUDA. Now we're gonna hardcode this for, okay. So let's properly, because what if the user passes in 24 and you don't have that? So if self.gpu greater, I think it counts from 0, so device count, raise a value error, so this will kill the app, right? Oh, and sorry, I forgot, or self GPU less than 0, we can't have negative GPUs. Invalid GPU device selected should be between 0 and, I guess we'll call this twice, we don't have to save it. Okay, self.gpu. Okay, oh god, I hope rough formats this, because I am, oh wait, here, because I'm oh, thank god. Okay, so nice. We reformatted with rough, UVX rough format, and we can try to run our app now because we have a single GPU. So if I want to be evil, I can put this as missing, right? But I don't want, this should be 0. For 0 is the same default, right? So we can do UV run -m score underscore based channels dot train dot score. Let's run it by default without overriding. Okay, and let's see, what is my now config well, let's look at Hydra config. Okay, it's a single thing, GPU 0, and this guy inherited it. So now the app is backwards compatible, right? Except if I do now, I can do GPU equals 1. I don't have 2 GPUs, so, oh no, not between 0 and 1. -1, right? Inclusive. Oh god, I'm over the line again. UVX rough format. Oh, it doesn't know what to do here. Okay, well, sure, this is ugly, we'll keep this. Right, because I only have 1 GPU on my machine, so this will read between 0 and 0. Invalid device. I guess this looks better like this. Self.gpu selected. There is a way to split f strings. Okay, fine. Let's just keep it for one time. We'll be over the line. Okay, good. So now we can keep going. Okay, so we solved the device. Now, of course, we're gonna nuke this whole thing and we're just gonna call this config at the end. But it's a nice way to have backwards compatibility, right? We should definitely nuke the arg parse though. Okay, this one is a big problem. And because we nuked the arg parse, let's deal, there is one more place where args appears. So, train. Oh, this is the channel you want to train on. Very important too. Train channel. String. CDLC. We're gonna give this. This is so. Now, if we actually know what the app is doing, this is really an important parameter. So this one is worthy of a missing. Okay. Because we want whoever's running this code, we want to force them to specify this one. So we're not gonna set a default. Now, maybe it's a bad choice. Well, let's leave it CDLC. You gotta be careful with these missing because you cut the simplicity of the app, right? Because you kind of want to show people, hey, if you just run UV run-m, whatever, which is already a bit long, we may need to rename this module. I can't, if I rename this score, it's, oh, sorry, it's train.score. I guess SBC would be better here, right? Yeah, sbc.train.score. Score-based, yeah, okay. So anyways, my point was if we want people to do this just for simplicity. So for now, I'm not gonna use a missing. Well, actually, there's an easy way to see backwards compatibility. What did I just delete from here? There's another way. Okay, so yeah, let's do it this way. If these guys had defaults, we'll keep defaults, right? So, okay, yeah, we'll keep a default. We should also verify that channel distribution is valid. And actually this should not, okay, I made a mistake here. This is not train channel because the config is already called train score config. This is just channel, okay? That's a bad naming choice. Like, why would you have a field train inside the data class already called train? And it's better because it's shorter. So here it's a string and we're gonna say if channel not in self.channel. Not in. Now I know these, they mean something, but it doesn't really matter what they are. It's just some A, B, C, D. It almost makes me want to Pythonize this. Nah, come on, let's not get too fancy. Because you could do like, I don't know, valid channels equals CDL plus the letters A, B, C, D. So we don't copy. But anyways, erase the value error. Same thing. Invalid channel distribution. Self.channel must be one of CDL. I'm just going to use this shorthand notation. A, B, C, D. Okay, we're done here. So we have self.channel now. We have to use it now. So where did I have args dot, it was called args.train. So see, this was bad naming because the train goes into channel, disaster arguments. So it's Hydra CFG.channel. And I think it was one more place. Yep, Hydra CFG.channel. And at the end, we're gonna, okay, good, more stuff now. Okay, now we're gonna do the nested ones. So, I can cut. Sometimes comments are not that nice, actually. To me, this code looks better now without comments. Sometimes they're a bit too much. Score-based channels, train, score. Gotta use the holy rough, okay. Another interesting idiomaticity question is if you have nested classes, which classes go first? The big one or the small ones go? I think I like the small ones first, right? So we're gonna have a subclass now because we want to get into config.model. So we're just gonna call it model config. Now this one we're gonna want to import in other files, which is, this is why, right? Because if I remember correctly, there's another script here. Yeah, no, it's a different LDMP model config. And wgan, let me guess, has another model config. Yeah. Okay, there's gonna be a lot of porting. We're not gonna do all of it on stream. We'll just finish this one. And yeah, there's hundreds of fields here. That in itself is something that may, I don't even know why the heck, Jesus Christ, there's so many parameters here. I guess there is a way around this. You can just, so what, where is kernel size used for? No, config.model. So LDMP, I'm just looking ahead a bit. So it uses hparams. This is bad design. I should have had this just taken the values unwrapped, right? Like I would rather have this have 6 arguments. This is another issue which I encountered. Sometimes you don't want to pass these nested objects around because you get unwrapping code, which is kind of annoying. Like I could just wipe these. Yeah, these 6 lines could go away if I had taken in 6 things. And not only that, there's another big reason. It would have allowed me to specify Python defaults. Because really, I don't think we need all of these. So the price to pay is that even if I port this, okay, we're gonna see it here. I'm gonna have a crap ton of numbers. So that's a problem for maybe in a future stream. We'll rework the code even more to just have some non-use. So the point is, do you really want your user to configure all of these? I highly doubt users want to configure the AMS grad of Adam. Yeah, this is still bad design, but for now we'll leave it like this. So model config. Okay, I'm just gonna crib from here then. EMA Boolean true default. EMA rate float 0999. Normalization string instance norm plus plus. Non-linear. Like, do we really want? I don't even think I'm pretty sure this code doesn't even. Okay, so now we also have to. Oh my God, we're gonna have to. I'm gonna have to validate all of these. Sigma dist string. But in a way, it is good, right? Because I mean, it's not good because you'd rather take these away. NGF int. Now if I'm kind of cheesy, I can leave it like this, but the problem is now, so here's this now shows the real risk of having too rich configs, because the way Hydra works is now the user can, okay, before actually the user will be able to just do uv run score based, sorry, -m score-based channels dot train dot score, and he's gonna be able to, they're gonna be able to override anything. So they'll say something like model dot non-linearity banana. The problem is the code will start running and it'll do a bunch of stuff. Eventually it'll crash, obviously, right? Because whatever model library I'm using here, there is no banana non-linearity. So that's why this is the point of post init validation, which validates it immediately. But the problem is if you have too rich of a config, now I have to go and look, and I don't even know. Damn, I'm gonna have to validate all of these. Like, so this is where typing also helps, because Boolean, for example, is a very strong type. So if the user tries to do model EMA 5, well, typing takes care of stuff too, right? This is not gonna work. It'll crash by itself. So you don't need, in the post init, you don't have to check for basic types, or if the user tries to do NGF equals 32.5. This tiny typing here is critical because it does a lot of post validation. But strings are dangerous in general because strings are nasty because they can be anything, right? Somebody can type curse words there, and so we're gonna have to do a bunch of stuff here. But until then, let's pass this to our big one now. So model, which will be a model config, will be a field. Oh, wait a second. This is my chance. Oh no, I see. This is my chance to pass defaults here, right? Model config. What was the syntax? Was it? I think this should work. Okay, so now we should have all these defaults in. So here's the nice part. I don't need all this stuff. I can just do config.model now. Whoops. Oh, not LDMP, sorry. So I can wipe all this and I can say config.model. Again, we're doing this just for backwards compatibility. Hydra config.model. Am I using config.model? Am I assigning to it anywhere? Oh my god. Oh my god, there's even more. Oh. Why are these in the model? This is the post init thing. Okay. Okay, let's not despair. Now, if I was really pedantic, I can do another subconfig here. Because this is a Sigma config, which has... We're gonna go insane though, but let's do it, fine. So there is a Sigma begin. Let's do it. Actually, it's not that bad, right? It helps me. It helps you separate them in your mind, and it's definitely more usable. Another thing is we're definitely gonna have to move this to a config.py file because this, well, not really. The code should be as long as it was, and we can leverage the post init now to instantly calculate. Oh no, because it needs, no, we cannot. Because it needs to reach into, okay. I can do a giant ass hack. I can post init that here and I can say self. Okay, so where is Sigma? Sigma, sorry, is a Sigma config now, which is a field with default factory. Sigma config. Now I can't do the post init here because in order to compute Sigma end, I need to know what Sigma class. You know what? Let's just move this here. That's better. We should not have, yeah, okay. And also this naming is dumb because it's begin and rate now. Okay, now I can have a true post init here. This is better. You don't want post inits to slice between. What I was gonna do is I can reach into that sub module, right? So I could have said here self.sigma.end equals, just type this formula, but use the num classes for here. But let's actually move it here so it's all self-contained. This is way more reusable. Actually, this is important for diffusion, right? Well, nobody uses these anymore, but it's for old people that do diffusion. And now we can say self.end. I'm just gonna copy this formula. And it's just self.begin times self.rate to the power of self.num classes minus 1. And this fits, oh nice, we saved the line actually. Okay, and this is still pass. Okay, do I have model.config anywhere? Config.model anywhere else? Please say no. Okay, these are just uses. Any more assignments? Yes, there's a, for God's sake, there's a step size to the last one. What is the step size? Where is config? Is it even used anywhere? Where is config model used after here? EMA. Okay, this is some stuff I just forgot. So we saved another line. Whoa. Sure. So why am I doing all this? What the heck is happening here? So I don't need best IDX. Do I even need all this stuff? Step criterion. I think I know what I'm doing here. Wow, this code is so bad. Okay, so check this out. Because I write it in the train script, I find an inference parameter. I'll show you what's happening. And in the test script, when I load it, I assume... No. What is the step size at... What is config.sampling? Oh, it's just steps each here. So I think this is all dead code, actually. Oh, wait. No, it's not. NCSM v2 deepest. Config. Does this guy use config.model? Yes. Oh, but doesn't use step size. Oh, come on. I'm just gonna delete this and we'll see if it... Well, actually, let's comment it. It'd be really nice to nuke all this code. This would be a big gain. Okay, so I think we're ready-ish. Not really, because we did a big change. So, we have Sigma config and we have model config to do validate values. I don't think we have time to... we're gonna go insane with these things, because we have to reach into that old NCSN v2 library and see what kind of activations or normalizations they have, and it's... I know it, but it's fine. Yeah, we're not gonna TBD, or I'll do this off stream. Now, what I want to do is let's use the model though. So we use it here. We did change some things though. There is a trickery here because... Oh, okay, these are gone. Code with if false. We'll leave. I know what this does. But it doesn't go anywhere to do clean this up and have a flag to actually use it. Because in the old days I used to run this manually, stop in the debugger and print the value and write it on paper and hardcore. I mean, this is why this is where I got these. Oh my god, this is where I got these values from. I just ran this code once. So yeah, this procedure should be automated. It would be really nice. I remember what this is. This is a trick we used to do in grad school. Okay, we'll leave it for now. And where do I have Sigma stuff? Is it because Yang Song needs it to be called is it because the NCSN v2 needs it to be called Sigma begin, Sigma end? I think it is, which is pretty bad. Oh no, I formatted a bunch of files. Ugh, I forgot to do it's fine. I did a mess here. I ran format without the line number. That's fixable. Where was I here? So I'm a bit stuck now because I have to look at the model and so does he expect it to be called Sigma end? Get Sigma's config. Yeah, he does. Okay. So we're kind of toast here. We can't use model.sigma. Because we use this external library which wants the config.map to be exactly like this. Okay, sure. Let's not break backwards compatibility for now, okay? So this will go and we're just gonna have Sigma begin. It doesn't really matter, it's just a different section. Sigma, well, Sigma end is in post init. So we'll have the old formula we had. Sigma end will be Sigma begin, Sigma rate, float 0995, and num classes integer 2311, self.sigma rate. There we go. So we can wipe this and we should be backwards compatible now. So UVXRough format, we're just gonna run the whole format, okay? Actually, let me just run this then. UV run -m score based channels dot terrain dot score. I don't see why this is not backward. I know what this is. It's lambda model config, like this. It has to be an instance. What am I doing here? Oh, I forgot to say default factory, obviously. And I don't think I need this actually. Okay, so this works. This is backward. Yep. Okay, good. So all the config works. Yeah. So we had to drop that Sigma thingy because the NTSN v2 old Yang song library, he wants the field to be called config.model.sigma_begin. So we can't get around that. We're not going to refactor. Okay, next one. Okay, now we're getting the hang of it. So optim, same thing. So data class. Obviously, we could do this with AI. It's probably gonna blast through it. Well, actually, you know what? Let's do that with AI. Yeah, let's not waste too much time because this kind of stuff is perfect with AI, right? So let's have some more fun with Gemini because we want to tell Gemini this. So, I want to tell Gemini this. Let's see. Do we know how to prompt? We should know how to prompt. Google Gemini, and I'm not using a Paint account. So I have the following code that I partially ported to Hydra plus OmegaConf nested configs. Finish it for me, please. And we can just dump the whole thing. I think that's it. Gemini, right? Because we want this. I'm just gonna, I guess I'll take these two. And this is really all I want, right? And this is actually pretty easy to figure out what I want from here. Yes, I know I'm moving from the monolithic and towards type state. So this is great for reproducibility. Thank you. There we go. So we get all this. Very good. It figured out to sync the data channel. Why the heck do I have... Okay, yeah, I see. Because I had argparse. Very good. Except one thing. Gemini's still on this dumb... Very good. So let's take all this. He still uses typing, which is really annoying. Everything looks good here. I don't like this. You don't need this in modern Python. You can just type directly with the list, the Python built-in list. Typing is kind of deprecated. Oh, that's it. He also, oh my god, what did he do here? Oh, never mind. I gotta delete this. Yup, so I have the thing, convert to standard dictionary. Hey, thanks for joining. I'm actually refactoring one of my older projects to use Hydra plus OmegaConf just to have a more modular config, so I can show you what the diagram that we have been messing around with. Oh yeah, something like this. So we had this old project which had arg parse, and I was using this sort of dot map for a bunch of config parameters. But then it was really bad because they were all written by hand and users could not override them without editing code. So then I said, okay, well, we want users to be able to just override config parameters from the command line, because that's sounds like more modern Python, right? So then I just migrated to a nested config solution, which uses Hydra and OmegaConf, which kind of looks a bit better. There's still a crap ton of config parameters, but okay, so Gemini did its job. So now we have a bunch of stuff here. Oh, let's see. There are some peculiarities here because I remember data loading on Windows behaves weird. So how do we resolve something like this? This is bad code. The default. So we want the default number of workers to be 4 on Linux. Otherwise, we want the default number of workers for PyTorch to be 0. I think this is a. Okay, this is a post init thing. We want to tell the user this. So if OS name is not POSIX and num workers is greater than 0, we're not going to raise an error here. We're going to set it to 0. We're just going to print a warning. Warning, Windows doesn't support num workers greater than 0 for PyTorch. At least my computer is busted. Resetting it using 0 workers instead. Okay, so this is another use of post init where you want to gently correct your user, and then we can leave it 4 now. Okay, so now the default is 4, so users running on Linux will get multi-threaded data loading for free. Oh, the program itself, well, it's let me paste it here. It's actually I would say it's some of my grad school work, which does I just pasted in the chat if you want to check it out. It uses generative AI for channel estimation. It's more of, let's say, it falls in the AI for science category type of thing. But it's an older repo that I used to work on like 3 years ago in grad school, and I kind of decided I just want to clean the code up. So I'm not doing any functional changes in this stream, not yet. I'm just making the code look nicer and better. But otherwise, yeah, you can check the repo out there if you're interested in that kind of stuff. Oh, what the heck is this? Not Hydra config.channel. It's config.channel. Okay, let's just try to run this. I think this should be it. Score based channels dot train dot score. No, I'm missing. Okay, so I messed up a parameter here in line 123. Why? Why am I messing up the file name here? Target channel, config.data.channel. So I don't have config.data.channel? Why isn't this set? What? Yeah, if you don't use Python, it's it has a bunch of stuff. Basically, I'm trying to make this code be friendlier to, well, you know, Python has scripts. So basically what I have here is a collection of scripts, and then you can run them. But the problem I had with my old code was that you couldn't override their parameters, right? Because I'm pretty sure in any programming language, usually you have command line arguments, right? Like parameter equals 5 or something, 6, whatever. So that's kind of what this library does that I'm using right now. It makes it, it doesn't change functionality of the code, but it sort of allows you to hook into Python parameters. So what was I saying here? Okay, so what is happening with this channel? Because it looks pretty nasty. Config.data. I see. So Gemini was wrong here. So I can't set these. Well, this is pretty bad because that means even my config.model doesn't have a sigma end. Yeah, that's true. Oh my god, I'm so dumb because Gemini did this thing. Okay, Gemini changed Gemini changed our lines here, which is really bad. I actually wanted it like this, sorry. Okay, so config, there we go. Now it should be fixed. So now if I look into config, I should... Structure of data config channel. So can I do channel is self.channel? Or can I do channel and non-pilots? This sync should happen inside here. So this is a post. Actually, this Gemini is not that good then. It kind of messed some things up here because we want to have something like this, right? So num-pilots is the second image size. Interesting. Okay, so I can't do this. Data config is not callable. But I can't have a missing field. Right, because the init will run nested, right? So I can't have this be missing here. Well, let's do it this way then. Let's do it cdlc, and we're just gonna delete the channel from here. Let's see, do I ever use config.channel directly? Yes, but I can just call it config.data.channel. Okay, let's try again. Okay, train score config does what? Oh, I see. I have to move the validation here now. Gotcha. Okay, very good. Oh my god, Gemini changed this stuff too. Sure, I guess I'll accept this. We're not gonna raise an error now. We're gonna... Okay, finally we're done. Okay, so the config should now all be populated. GPU 0. Okay, so everything should just run backwards now. Okay. Whoops. UVX rough format. Okay, so then I can just run. Everything should just hopefully start training on device CUDA 0 for whatever. This should be it. Please train. No. Interesting. There's a logit transform, and I did not have this in the config before. So let's see, logit transform, self logit transform. Where is it coming from? Oh, it's just coming from config. What? Okay, I gotta go to the web on this one because it's freaking me out now. So you're telling me if I look here in source and what we have today in train score, which is there's definitely not a logit transform here. Is there a logit transform in the code base at all except for that thing? Oh, I have to be signed in. Okay, I have to search this in my other window, sorry. Because I can't leak all my repos. Well, shit, it's in a bunch of files. Damn. So where the heck do I override this now? Okay, let's not panic here. Logits config.data.logit transform. Let's do it this way, because I messed up the UV format. I forgot to put the number of lines in rough, so I edited a ton of files. But no. Rough works for sure. We should not do silly things. But nevertheless, let me add what score-based channels train score. This is the file we changed, okay? Everything else, goodbye. Restore. Okay, so it's back to usual. Okay, so now what is up with this logit underscore transform? Okay, well, here's the thing. Let's do it properly. So git commit -m, almost working. So rework config into Hydra and OmegaConf. Because we should not panic, because this is very easy to debug. We just check out the main branch. There we go. And we're just gonna have to, not the main branch, let's check out the rough one, because I know I ran that and it worked. So we're gonna check out rough format. Okay, done. And let me stop exactly here and see what this is, because then I can run exactly the same command, right? uv run -m train score. There we go. With uv environment, everything nice. I don't know what this is. I have never seen this, but we know the code runs, so we don't care. Yeah, there's definitely not the logit transform here. Okay, so I don't know what. Oh, come on. It's not even like, oh, I know why, because it's an NCS MV2 deepest. Sorry. Deeper. Deepest. Nice naming. Again. So clearly the code runs, right? Because it just ran past this point. So we just gotta figure out where the heck is this coming from. But who would ever touch config data if I don't set it here? Did I miss a line somewhere? Config.data? Spacing list? Okay, so let's see. We're here. So what is config.data? Oh, so logit transform is none. Don't tell me I've been running this code wrong all these years. Like after the repo got... There's no way, dude. So self-logit transform is this is basically a singleton none. And where does this get used? What is not self.logit transform? Oh, it's supposed to be a Boolean. And it evaluates to false. Yeah, so the dot map was making this become a default field, which is an empty thing, which... Okay, nobody mentioned anything about this. Because I've not been using... So I haven't been doing this branch. No, sorry, I have been doing this branch 2 times x minus 1. I guess it doesn't matter in deep learning, right? If you do this... This is pretty wild though. Oh, I see, it's just an input scaling. Damn, so is it, what is rescaled? Self.rescaled. So next, self.rescaled. It's also a dot map because I never set these, so they're implicit. This is the risk. I can't believe this happened. Like, this is the risk of these dot maps. See, I remember what the problem is now. So the problem with these dot maps is, let's go back to the main code, the old code. Okay, it's dot maps are a disaster. Oh my god. Like, okay, let's... Wow, this is pretty wild. So I've been using this code, not wrong, but I unintentionally on a branch. So here's the thing with dot map. So I have a config, which is dot map. If I type config.banana, obviously I didn't set it here, but it doesn't return an error. It actually returns a new dot map and it creates it on the spot. So now next time I look into config, guess what? It has a banana subconfig. And not only that, this evaluates, this can be treated as a Boolean. So you can do if on it. So then these two guys never existed, literally. And that's why OmegaConf is very strict. If you try to reach into a field that doesn't exist, of course you're gonna get the hard error, because that sounds sane. But, so these are both falses because they're empty things. So this is true. So then I was taking the input and I was doing 2 times input minus 1. If I remember correctly, I had already normalized my data to be between minus 1, 1. So if you take minus 1, 1 and do 2 times, that puts it to minus 2, 2, minus 1, minus 3, 1. This is pretty wild. So I've actually been skewing my data negative. We have to leave it. We gotta leave it like this. Jesus Christ. We have to leave it like this for. Okay, so now we can go back. We have to define these. So these are booleans, right? They're not used anywhere else. They're supposed to be booleans. True, false. Yes. So I have been rescaling my data all these years. And not only that, the tens of papers that use this code. Well, it is what it is. Maybe they... this is why it's good to revisit. This is why it's good to use... I mean, okay, we just learned the massive ass lesson then, right? Just use modern Python stuff, not things done by hand. So I can go back now to what was it called? Hydra and OmegaConf. Okay, and so in order for this to work, we have to have those fields in data, and they were called, what were they called? But wait, they're both false. I think even the original NCSN v2 code is messed up, because if I put these two false, so Boolean false, right? And the other one was called rescaled, also a Boolean, also false. Okay, now it should run, I swear. So let's see, uv run -m, score based channels, dot train dot score, unless there's more defaults, which I'm like, I don't even want to think about that, dude. Please, Lord, just let this run. So if I find other stuff that was like that, yeah, okay. So we learned a massive ass lesson. Like, don't always check your configs. Like, yeah, there we go. Okay, so now it's running. Okay, so the rework is done now. Git diff, just minor difference here. Well, minor but critical difference. Git add src score based channels, train score, commit -m, add missing fields. So I'm curious now, because also now the NCSN v2 code is not ours, but whoever named these seem like to be named wrong, because not rescaled hits. Oh, I see. This means, is the data already rescaled? And I tell no, but that is wrong, because yeah, because we can see why. Because if I go to utils or models.loaders, there we go. We normalized the data already. And the default normalization is global, I believe, right? Yeah. So we already take out the mean. Well, we divide by standard deviation, so they are kind of, yeah, my logic is right. So there you go. So now we learned something, whoops. We learned, what did I oh, sorry, did I mess up the stream? No, I didn't. we learned something very important, that we really need tight configs that are, well, first of all, you want them to be type checked. Okay, so now let's mess around with overrides, right? Because we did all this sausage. At least now we can override anything we want. So assuming I understand what, again, remember, we have to do, we still have to type check things. To do validate options. Because, for example, now a user can run, let's say the user wants to run exactly this training, but they want to change the nonlinearity. Well, they just do it from the command line. It goes like this. What's the config name? It's model dot nonlinearity, and let's say I know ReLU is valid, and that's it. So I run this now. I mean, again, this is fancy argparse, but it allows you, it has stronger validation options instead of you can pre-validate things. And that's it. I'm assuming ReLU is an option. There we go. It's training a model, which before users could not do that from the command line. They had to edit the code. And so they have to, and then I can also change 3 things at once. Let's say I want model NGF4, which is a smaller model. I remember this. And then I also want optimizer, what is optim? Yeah, it's optim dot learning rate to be 0.001. So now you can see how you can, because it's all, another thing is you can now launch controlled experiments, right? Before it wasn't possible because all the parameters were in Python, which is horrendous. Now I can write the shell script if I'm on Linux or Bash or whatever, where I just launch some of these in parallel. And of course we have the, we got the GPU argument too. I don't know, there's a bunch of other stuff here, like training dot batch size equals 64. Right, so all this should just work now. Oh, it's NGF. Oh, see, I made a typo, and then OmegaConf and Hydra, they picked that up instantly because it says model NFG does not exist, so could not override it. I made a typo, I called it NGF. It should be NGF. And that's it. So now it magically works. No functional changes. The code does what it used to do. But now I can more easily change parameters. And that is what we wanted to do all along. Let's do this cleanup too, I guess. Yeah, so we also clean up. Although if we're being really pedantic, that should be another PR, another branch, but it's fine. Clean up unused code. Okay, so now my job is to, I need to finish some of this validation. I guess we can start some of it. Like, let's see. So what is normalization? So if self normalization not in, raise value error, invalid normalization, self normalization. Well, actually, I can do it like this. Valid normalizations. I can just make it this and not invalid normalizations. Should be one of valid normalization. So I just need to now, and we can repeat this for, well, let's see, normalizations. Let's try to shorten this a bit. Always use shorter variable names. We have also active nonlinearities, I guess, because he doesn't want to call them. Okay, so then we want to check. And we also have sigma dists. And this should be self nonlinearity. And this should be self sigma dist. This should be nonlinearity, and this should say invalid nonlinearity, invalid sigma distribution. I just gotta find the right values now, and I have to dig in the NCSN v2 code, but it's I've done worse things. Oh, here it is, normalization. Oh my god, there's so many, right? So it's non-norm. Yeah, it's all these guys, which is a bunch of stuff. Actually, it should be these guys, because we're not doing conditional models. So let me just take these here and just paste them quickly. So we have valid normalizations, batch norm. This is just AI stuff, but most of these are kind of old, to be honest. I think everybody uses instant layer norm these days or something, or instance norm. Okay, so normalization has to be one of these. Good. Activation, nonlinearities. They have to be where? It should be ALU. Layers, maybe. Oh yeah, here it is. ALU, ReLU, swish. ALU, ReLU, L, ReLU, swish. I'm just gonna memorize these. ALU, ReLU, L, ReLU, swish. Everybody swish. Okay, swish is still pretty popular. Everybody uses swish these days. And the last one was sigma distributions, which I believe are geometric and linear, if I remember correctly. Where the heck will we find that? Somewhere. Where would this be? Geometric. I just roughly get sigmas. Aha, geometric and uniform. Okay. And that's it. Let's UVX rough format SRC score-based channels, not in it. Train score. What is it? Line length 108. This is my, yeah. Okay. And the diff that we have is, okay, we validated the options. Oh, interesting. This reverted my thing here, which is nice. Okay. So validate model options and reformat. Train score. Okay, so let's check if it still runs. So now if a user tries to run with, oh, actually let's keep these, right? So 64, and now let's say they want to change the nonlinearity. Oh no, we have it ReLU, right? Let's say they also want to change the, I don't know, whatever, normal. Well, let's see if this runs. And then if a user picks, again, same mistake, NGF, not NFG. Again, OmegaConf takes care of us. Oh, not NGG, sorry, NGF. Okay. Okay, this works. And now if a user gets a crazy idea and they want to run with 10H nonlinearity, which is not supported by this model, instead of letting it crash or letting it try to load, it just crashes fast and outputs our nice message, which also informs users what you should, right? Because, I mean, we wrote this, but this is very helpful for users, right? Invalid nonlinearity. And that's it. So I got a bit more stuff to validate here, like the optimizers probably Atom or SGD. Not too much, to be honest. Channels validated. No, norm channels. This is ours. This is important. So if self dot. Actually, let's do it like this, right? So channels, because you always want to give feedback too. So if channel not in channel, so you can say should be one of channels, and we want to say the same. Norm channels global. Now this is my code. I don't remember what it is, but I think the options are entry wise. Here's an interesting thing. The norm can be a list too. So very good. So the norm channels is either a string or a list of floats. Very interesting. This is a more advanced case of post init now. So, well, again, this is bad code because at the time I decided I either have the normalization be a string or I let the users input their own two normalization constants for the mean and standard deviation. Maybe this is not that bad design actually. So now in OmegaConf, very good. So we have a list of float and now we have a bit more advanced validation. So first of all, if the type of norm channels is string and it's not in norm channels, then we want to raise an error because the user tried to invalid data normalization string. There's a trickery here because if I don't put this, it's gonna fail if a user specifies a list of float, right? Because a list of float is not in the list made out of global and entry wise. So you have to check the type too. Should be one of norm channels. Otherwise, if the type is, what's the other validation? It's if it's list and the length is not 2. Because a user may put in from the command line a list with 3 numbers, and that doesn't make any sense because the convention invalid normalization floats should be exactly 2 values. Okay, so now if I try to, let's try to override this. All right, so let's say I do norm.channels is entry wise. This should be fine. Unions really? Is OmegaConf limited here? Well, this is kind of a bummer that I guess it's warning me that this is bad code and you should really not do this. Yeah, you would think, like, seriously, this is not supported. Yep, this is exactly what we have. We have a union between an int, or I mean a thing, and some other thing. Oh, okay, this guy is saying just use any for typing, which is like anything in the world. Okay, so we'll do it this way. Now, this is an even more advanced example. What this guy is saying is this is not supported. So the workaround is there's a magic any if you import from type. Now, obviously, you should not use this because it literally means it could be anything. Like, if it's from typing import any. Now, this looks horrible. If you use this everywhere, then it defeats the whole purpose because it's not checking anything, right? You're basically telling the user, and not only you're telling the user, like, again, OmegaConf will check the types too. So let's try some more basic type checking. Like if we do something like, you know, let's say I try to do numpilot equals 23.3. instantly crash because, sorry, it's what is it, data non-pilots. See, again, it warns me that, okay, there we go, value could not be converted to integer, right? So, but then if I start using anywhere, that's a disaster, right? Because I'd lose all these checks. So now a user could run my app with 63.3, and of course the code will crash, or maybe the worst part is if it doesn't crash. If I wrote assumptions, like I take the floor, and that's a silent error. Now the problem they're saying is you can't do a union between a list and a non-list or something like that. So, but we can still solve this because we can post init check if type. This is the brute way to do it, right? Not in what do you say, string and list. Now this is, Python has another quirk. This doesn't work. You can't check at runtime if something is a list of, you can check if it's a list, but you can't type list of float. Can you? This is a good test actually. So if I have x equals 2.3, what is type of x? So then it's a list. So then if I do type x equals list, this is true. But if I do type x equals list of float, yeah, this doesn't work. It does not work. So very careful here. There's another trap. So first we can only check if it's a list. Okay. We can raise a value error. And we can say data normalization should be, again, this defeats the whole purpose of OmegaConf, but it's a special case. They should really support, it's very annoying that they don't support string or list. I didn't even know this, to be honest. I guess what? They're implicitly telling you this is bad coding. You should not code parameters that can either be a thing or a completely different thing in terms of like a list or a dictionary or a number. That's a bad parameter, which I can accept that. Should be either a string or list of floats. But well, actually, let's make this message accurate, or a list. Now this is not full validation. The really full validation thing to do is so we're checking for the list. If it's a list, we're checking if it's 2 elements, or so this is what we want. We want to make this check more fancy, because so if it either doesn't have 2 or if they're both not floats, right? But I think there's a trap here though. Shit. Because if the user types them 0, 0, let's see, is the type of 0, it's an int but not a float. I think we're dead here. There's no way around this. Basically, this implicitly tells you have to force users to type decimal points in the command line. So users should type something like this. Because I was gonna check the type, so I was gonna do or type of x0. Let's do it this way. Or type of x1 is not a float. This is a very strict check though, not x, self-done norm channels. But this becomes an extremely strict and annoying check, to be honest, because, okay, UVX rough format. SRC, score-based channels, train score, line length 108, okay. So, yeah, this is a very aggressive check, because now if a user tries to run with, what was it, data dot norm channels 0, 0, this will crash. Yep. Oh no, sorry. I hit the non-linearity. Let's say we do that valid. Yeah, there we go. Should be exactly 2 floating point values. So it doesn't see these as floats. So basically what I'm telling users right now is no, you have to type 0.0, 0.0. Now OmegaConf and Hydra pick these up at floats, and there we go. Yeah, so unnormalized channels. So it's a strict check, but we'll leave it for now. Oh yeah, there's divide by 0, obviously, because I'm dividing by standard deviation 0. So okay, not that it matters. So because we're not using that as a default. So git add source group channels, train score, git commit, stricter validations for data config. Yeah, it's strict, but it's not the worst. Okay, well, that's it for today. So then I have to go through all of these. We have a ton of, we can delete our play field now. So there's a lot of work for me to do because I have to take all these other scripts by hand. But I hope this was interesting. So thanks for tuning in, or thanks for watching on YouTube. And we'll see you next time with more coding content.